Hello everyone, I'm Dr. Vivian. So welcome to my channel. So in this channel, I will give some lectures about probabilities. In our previous lectures, videos, we already talked about what is a sample space. And if we want to know how many elements in one sample space, then what's the counting technology of them. So in this videos, I will introduce one more method to counting how many possible outcomes we will have in one sample space. The name is permutation. So permutation, this is a way to counting how many outcomes we will have in one sample space. But there are two types of permutation. This is depends on what is our experiment. So the first one is permutation of subset. So of permutation of subset. So now what is our experiment? So for this experiment, we want to select one subset of our R elements from N different objects. So for this one, this is our experiment. So now we have several important information. So the first thing is how many elements we will have in this subset. This is we have select R, and how many total outcomes we will have. So this is number is N. But there is one more important information is different. So what's the meaning for different objects? So you can imagine if we select one item from 10 objects. So if the whole object is same, then no matter which one we select, they all get one result for our sample space. So select one black ball from 10 of same black ball, then there is only one case, is our sample space is only one black ball. But if image all of the 10 balls have different color, then for our select, we select one ball from these 10 different color balls, then they will have 10 different style of our sample space. So in our sample space, we have 10 outcomes and 10 possible outcomes. So that is the meaning for different objects. And also, if we select two items from same balls, so we select two balls from 10 black balls, then no matter the first one which black ball we select, they also for our sample space, the only possible outcome is we have two black ball. However, if this ball have different color, so we first select a red one and then select a green one. Or on the other case, we first select a green one and then select a red one. This is two different select process. So this means if we have n different objects, then this will imply the order is matter. So this means this is ordered arrangement. So this is what the meaning for different objects. So then for this one, we also give us the formula for this one. So here for the number of permutation, here we denote this by P and N and sub R. So this means this is a permutation, select R elements from N different objects. So this is equal N times N minus 1 times N minus 2 until times N minus R plus 1. So here, by this equation, we will times R different numbers together. And also, we can use the factor to denote this. So this means we can rewrite this as N factorial over N minus R factorial. So this is same with our previous equation. It's also times n minus 1 until n minus r plus 1. So now let us give one example to explain this. So in this example, this is if we have a license plate with 4 letters followed by 3 numbers. And then how many license plates we can have without repetition. So this means if we have a plate, and this plate we have about A, B, C, 1, 2, 3. Because here we have 2A in this plate, so this is a repetition, and that means this is not a correct or legal license plate in this example. So for here, what we can think about this example. So we can treat this as a two-part. The first part is about letters. So what this means, because in this license plate, we will have 4 letters. So that means we will select 4 letters from the total possible letters. So this is from 26 letters. So now we will have in this one, we have R is equal 4, and now N is equal 26. And so for the numbers, what we will have this is, we will have 3 letters. So we will select 3 numbers, and this is from total 10 numbers. So the total 10 is from 0, 1, 2 until 9. So now we have this, let me rewrite this as R2 equals 3, and our N2 is equal 10. So for letter, I use a sub 1 for letter, and I use sub 2 for the numbers. So here, this is a question. So this experiment is combined with 2 cases. One is for letter and the other is for numbers. And for each of them, this is about permutation of subsets. So now what we can use is we should use our formula to compute this. So let me write this formula here. So our formula, this is PR, and for the first Pn1R1, we will have this is, by our formula, is n1 factorial over n minus r1 factorial. So this is for letter. So we have 26 factorial divided by 26 minus 4 factorial. So for our answer is 26 factorial over 22 factorial. Okay, so this is for the letters. And then for the second part, about the numbers. So now we use the N2 and R2. So now for formula is still same. It's also the numerator is about n factorial and the denominator is n minus r factorial. But now we plug in the information about numbers. So here the numerator n2 is equal 10 and the denominator is 10 minus 3 to factorial. So now if we compute this, it's 10 factorial over 7 factorial. And then what is our number of all the possible outcomes in our this sample space? So this will need the information from our previous video, the multiplication rules. So here we have 2 steps of this experiment, 1 letters and 1 numbers. And then if we want to combine them, this we will use the multiplication rules. So this is the result for the first steps times the possible number of results or outcomes for the second part. So this is 26 factorial over 22 factorial times 10 factorial over 7 factorial. Okay, so this is about what is a permutation of subsets. We select R elements from n different objects. So here different is very important. And then I said for the permutation, we have two types of permutation. And the second one is permutation of similar objects. So here you can see here we have a word similar. So what this means? This means now for our objects, we have some of them and looks very similar with each other. So we can treat them as similar objects. So here, this is if we want to select or say we want to, the experiment is we want to arrange about several n in total is n objects. So here in total we want to arrange n objects with R types. And for each type, we will have the different numbers of this one. So here this means which where we have n is equal R1 n1 plus n2 until plus nr, and which R1 here n1 are of one type and nr are of R's type. So for this one, now in total we still have n objects, but some of them look very similar to each other. So you can think if we still have 10 balls, but 3 of them has color as red and the other 7 has a color as green. So now it means we have 2 types. And for type 1, the red one, we have n1 is equal 3. We have 3 red balls. And then for the type 2 green balls, we have 7 balls. So now we have n2 is equal 7. And then for this one, if we want to compute the number of outcomes in one sample space to this case, so the formula for this is the numerator is still n factorial. So this is same with our previous permutation of subsets. But now the denominator is different. So the denominator first is n1 factorial times n2 factorial until times nr factorial. So here this is with the meaning and is a formula for compute a permutation with some similar objects. So now let me give one example to explain this. So let's look at this example. So here we have a hospital officer want to get a schedule several series. So for this series, so what they will do, surgeries. So what they will do, they have 2 brain surgery, 3 knee surgery, and 1 shoulder surgery. So here, this means now we have 3 types. So the type is a brain, the knee, and the shoulder. So here we will have our R is equal 3. And then for the brain one, this is our first one. So we have this is our N1 is equal 2. And then for the knee, we have our N2 is equal 3. And for the last one, the shoulder one, we have our N3 is equal 1. Okay, so this is the information we have from the question. And then if we want to use a formula to compute this, what we need first is we need to get how many surgery we need to schedule in total. So here this is sum up the N1, N2, and N3. So this is sum up of 2 plus 3 plus 1, and the answer is 6. So now the total surgery we need to schedule is 6. So by this one, the next thing is we can use our formula. So the number of our outcomes is n factorial over n1 factorial times n2 factorial times n3 factorial. And for this question, n is equal 6, so it's 6 factorial divided by 2 factorial for n1, and then for n2 is 3, and for n3 is 1. So this is our examples. So by this one, we will get how many possible schedules we can have for this 6 surgery with 3 different types. And if you use your calculator, you can get the final answer is 60. So this is about how we can use permutation, 2 types of permutation, permutation of subsets and permutation of similar objects to compute how many possible outcomes we have in one sample space. So in our next videos, we will continue introduce one more new methods to computing the possible outcomes we have for one sample space. So if you like my videos, please sum up my videos and my channels, subscribe my channel, and I will see you in my next video.